Okay, so this video is going to go over Descartes' rule of signs, and I wrote page 243, but really this section starts on page 242. You might want to pause the video as you get your book open to that page because you're going to need to reference it. So page 242, again, we're going to start by talking about Descartes' rule of signs. And I'm going to read on page 242 at the top here, right under Descartes' rule of signs, where it talks about in section 2.2. So it says, in section 2.2, you learned that an nth degree polynomial function can have at most n real zeros. So that means x to the fifth is going to have at most 5 real zeros. That means it's going to touch the x-axis at most 5 times. It says, of course, many nth degree polynomials do not have that many zeros. For instance, x squared plus 1. Think about what that graph looks like. That is a parabola moved up 1. Well, is that ever going to cross the x-axis? No, it has no real zeros. Okay? And f of x equals x cubed plus 1 has only one real zero. Okay? The following theorem, Descartes' rule of signs, sheds more light on the number of real zeros. So this Descartes' rule of signs, what it allows us to do is take our polynomial and look at some information about our polynomial and decide how many possible real zeros can there be. Okay? This box right here, I am not going to take the time to write this out. I would pause the video to write this out, and then we're going to do some examples together. So while you're writing, I'm kind of going to talk about it. So it says, let f of x be, and here's our polynomial. So all it's saying is it's going to start at some degree, okay, and it's got coefficients, okay? And right here, number 1, the number of positive real zeros. So these are numbers I can actually see on the x-axis of f is either equal to the number of variations in sign of f of x or less than that number by an even integer. And for right now, just write down what it says, and we'll go through an example, and I think that ending part will make more sense. Okay? The number of negative real zeros of f is either equal to the number of variations in sign of f of negative x or less than that number by an even integer. So again, these are the same. However, when we're looking at positive, we just look at f of x. And when we're looking at negative, we look at f of negative x. Okay? Now, what does a variation in sign mean? That means that it changes. So here, if you look at this polynomial, here's f of x. We've got 3x cubed. That's positive. Then the next one is 5x squared. Well, that's negative. So there is one variation in sign, or one sign change. It went from positive to negative. Now if I look, this is negative 5x squared. That's negative, where this went to a positive. Okay, and then again we went from positive to negative. So this has 3 variations in sign. Okay, so that's what it means, variation in sign. It's going from positive to negative or negative to positive. Okay? So we're going to do a couple of examples looking at Descartes' rule of signs. So again, if you didn't have a chance to write that down, go ahead, pause the video, make sure you write that down, and I'm going to do a few examples with you. The reason why we want Descartes' rule of signs is because eventually you're going to be given a polynomial of any degree, and I'm going to say find all the real zeros. Well, Descartes' rule of signs allows me to figure out how many possible positive zeros there are, or negative zeros, and that allows me to eliminate some things. All right, so here's example 1. f of x is equal to 3x cubed minus 5x squared plus 6x minus 4. All right, positive real zeros. For this one, remember, if you look back in your notes, you just look at f of x. So here's f of x. We go from a positive to a negative. That's one sign change. Then we go from a negative to a positive. That's two sign changes. Then we go from a positive to a negative. That's 3. All right. So we've got 3 total changes. Now remember what it said in your book. It said that it's either equal to the number of variations, so we could have 3 positive real zeros, or less than that by an even integer. Well, it's either 3 or 1. Wouldn't you agree that that is less than 2? 2 is an even integer, so I'm always going to be counting down by 2. So for positive real zeros, there's either going to be 3 of them or 1 of them. It's not possible to get 2 or 0. All right, now let's look at negative real zeros. Okay, for this one we have to do f of negative x. So this one takes a little bit more work. So I've got to take my polynomial and go back through, and I need to change everything to a negative x. So it's going to become 3 to the negative x cubed minus 5 to the negative x squared plus 6 times negative x minus 4. All right, here, negative x cubed, that would be negative x times negative x times negative x. So that's going to stay, or excuse me, change that to a negative 3. Here we've got minus 5, and that's negative x squared. So that's going to stay minus 5x squared. Here we've got 6 times a negative x. This is going to become minus 6x minus 4. So now I can look. Now that I've changed this to f of negative x, I can look. We went from negative to negative to negative to negative. So for negative real zeros, there are none. It's not possible. Okay, let's try another example. And this is all Descartes' rule of science can tell me. So for positive, I'm either going to have 3 or 0. For negative, I know I don't have any. So I should not have any negative zeros. This graph will never cross the x-axis in the negative part. So let's do another example. Let's say we've got f of x is equal to 4x cubed minus 3x squared plus 2x minus 1. All right, positive real zeros. All right, look at how many times the sign changes. So here it went from positive to negative. So that is one sign change. Then we went from negative to positive. That's 2. Then we went from positive to negative again. That's 3. So for positive real zeros, again, we can have 3, or remember, it's less than this number by an even integer. The even integer we're going to use is the smallest one. That's 2. So minus 2, we would say 1. And how do I know to stop at 1? Well, it's not possible to have a negative number of zeros. So we can either have 3 or 1. Now, for negative real zeros. Remember, this one takes a little bit more work. We need to change this to f of negative x. So that means it's going to become 4 negative x cubed minus 3 negative x squared plus 2 times negative x minus 1. Okay, then you need to go through and simplify. So here, a negative x cubed is going to become a negative x, because again, it's negative x times negative x times negative x. Okay? Minus 3 negative x squared. That's going to make this positive, so that's going to be staying minus 3x squared. Here, we would have plus 2 times negative x, so that would be minus 2x minus 1. So again, look, we've got negative, 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 negative. There are none, or negative real zeros. Okay? Now, that's not always going to be the case, but it just so happens that our first 2 examples, there are no negative real zeros. Okay? Now, let's say you had 5 sign changes. Then for our positive real zeros, we would have 5, 3, or 1. Or 2 sign changes. You'd have 2 or 0. So it just depends on how many signs or how many times the signs change. Okay, so again, this is Descartes' rule of signs. This allows us to figure out possibilities of positive and negative real zeros.